Previously we talked about frequency tables, and this problem has one. It's this table right up here. And what it's showing is the scores on some test and the number of students who got that score in the test. So you've seen that before. What we've got today is something that'll probably look familiar, but maybe it's got a name you haven't heard of before. It's called a histogram. And a histogram is like a bar graph that's used to represent these frequency tables. And typically in a histogram you'll have these bars that are a certain width, and the width of the bars represents the range of this first column. So these are all 10, 51 to 60, 61 to 70, they're 10 apart, so the bars are all the same width. And then the height represents the frequency, the number of students in this case who scored that in that particular range on the test. So if we're going to choose the right histogram here to go with this frequency table, all we have to do is make sure these numbers match up with the heights that we see on the bars. So let's look at this. The first one, 51 to 60, has a frequency of 3. So what I'd do is I would go down and look at the bar that's labeled 51 to 60, which is this one, and make sure that it goes up to 3. And it does. There's 3. Let's look at, we've got several choices here. Let's look at B. B, 51 to 60, goes up to 10, so that doesn't match up. So B is out. In choice C here, 51 to 60, that does go up to 3, so that's okay. 51 to 60 and D goes up to 10, so we can reject that one too. So we've eliminated 2 of them. We've just got A and C to look at. So let's look back at our frequency table. Let's see, 61 to 70 says 4. So I'm going to look on my histograms here, 61 to 70. Yep, that goes over to 4 in A, and in C, 61 is the same thing. That also goes to 4. Looks like 71 to 80 is different though. 71 to 80 here is much shorter than here, so that's where the difference is. 71 to 80 should go up to 10. Well, in A it certainly doesn't. It only goes up to 4. And in C, 71 to 80 does go up to 10. So that looks like it's the right answer since we've eliminated the other ones. But let's just double check. We've got 81 to 90 should be at 8. 81 to 90, that's at 8. Good. And then 91 to 100 should be at 3. 91 to 100 at 3. Yes, indeed. So C is our answer there. That's a histogram representing a frequency table. This problem says which statements are true about the histogram. And the histogram is this bar graph here. Since the columns are all the same width, you'd expect them to all be the same size ranges. This one is 56 to 58, so that's a 56, 57, or 58, that's 3. 56, 9, 60, 61, that's 3. 62, 63, 64, that's 3. It looks like they're all 3. These are representing heights of students. The title at the top says heights of students in Harmon Middle School. And then here, this says number of students. That's the frequency. How many students fit into each height range? So let's see. It says which statements are true. Let's read the statements. Statement A says the interval 56 to 58 inches has the fewest students. So I would look at that interval, 56 to 58, and it's the shortest bar. It's less than 5, I would guess, by looking at this. All the other bars are taller, they have more students, so that's true. B says each interval is 3 inches, and yeah, they are. We mentioned that before. You can look at all of them. They do have a range of 3 inches, so that's true. C says the interval 65 to 67 inches has the most students. So here's 65 to 67, and yep, that's the tallest bar. It looks like it has almost 40 students in it, so that's true. And D says all of these statements are correct. So that would be the right answer for that problem. So that's a little bit about histograms.